Let's get some more terminology and concepts about models out of the way. Like I said earlier, most of the time, a lot of learning is about learning important terms properly, understanding the meaning of the terms. Once you understand the meaning of terms very clearly, then the rest of the stuff actually becomes quite easy. And conversely, if you're not very clear about what certain terms mean, then later on, when somebody is saying things by using those terms, then obviously you're not going to be understanding those things very clearly. Okay, so that's why I'm taking a lot of pain to make sure that you understand these terms very well. Most of the time, everything else is actually quite simple and straightforward. Okay, so here's a dirty little secret about models. Okay, and again, I'm not talking about fashion models, I'm talking about the kind of predictive models that we are going to be building. And in general, there's the term model used in a scientific sense, and that's what I'm talking about. Well, the dirty secret is all models are wrong. Okay, all models are wrong. No model is correct. The point is, some are useful. And that's where we are interested in models. So long as it's useful, I don't care if the model is actually not exact because it's giving me some benefit. It's making some part of my life easier. It's making some things more convenient for me. That's it. Okay. And this was a statement made by a very famous statistician called George E.P. Box, who is also the inventor of the box plot. A very famous statistician, and this is the point that he made about models. What do you mean by the term all models are wrong? Now, wasn't it the case that our model for calculating the total cost based on the weight, was that not a correct model? In every single case, the model gave correct answers, right? So why do you say it's wrong? Well, the point is models are wrong in the sense that the model is not the real thing. Right? I might have a model of a building sitting on my table. That's only a model of the building. That's not the building itself. Okay? I have a model to predict the price, predict the cost based on weight, but that's not the real thing. Right? The real thing is if you go and look at all the data. We didn't look at all the data. We looked at only 10 rows. And based on those 10 rows, we came to a conclusion that may not be correct. Okay? So a model is only a representation of the real thing. The model is not the thing itself. And only the thing itself is correct. Right? I have a model of a building. No, that's not. In order for a model to be correct, it has to be the building itself, in which case it's not a model, it's the real thing. Okay? So in this sense, the model is not the real thing. It is only a representation of the real thing. And therefore, being a representation, it is going to be missing some of the details, and therefore it's wrong. Okay, it's not getting all the details right. So for example, model is different from the real thing. Now you may say, what is this? Well, this is an interesting plane called the Dreamlifter. It's a plane made by Boeing, and the purpose of this plane is to carry parts for other planes. Right? So for example, suppose some plane is being made assembled in, let's say, in Toulouse, in the Airbus plant in France, but some of the important components for that plane have to go from the US. Well, the Dreamlifter is the one that actually takes those kinds of large objects. This is a huge, giant airplane. Anyway, I'm getting sidetracked here. The point here is, well, is this a plane? Not really. This is a picture of a plane. This is not the plane. The actual plane is the one that you see flying. Okay, so in that sense, this is a model of the plane. Okay, so it's not correct because this is not the plane. This is only a picture of a plane. It's only a model of a plane. Okay, but is it useful? Well, it is useful. It's not useful in the sense that I cannot fly in this plane. I cannot fly in the picture. I can only fly in the real plane. But it's still useful because if you want to tell somebody this is what the Dreamlifter looks like, well, they can look at it and they can get an idea, right? They can see what kind of a shape it has, how many engines, jet engines it seems to have, how many wheels it seems to have. It doesn't have any windows. We are getting a lot of useful information about the model. So it's useful for some purpose. It's completely useless for other purposes, right? I don't know how much it weighs from this model. I cannot obviously fly in it, right? And I don't know how big it is. Those things we don't know, but it is useful for certain purposes. Okay, so that's the whole idea. So whether a model is useful or not depends upon your purpose. Okay, so here are two wrong models of an apartment. That's one model. This is another model. Both are models of an apartment. They are both wrong because they are not the apartment. They are only some representations of the apartment, but each is useful in its own way. Right? If you want to get an idea, if you're thinking of, let's say, renting an apartment, somebody shows you this picture, you say, yeah, I like it. It's the kind of layout that I want. Or you may say, no, I don't want this. I don't like so much of openness. I don't like so much of sunlight coming into the room. I don't like. Well, it served a purpose. This gives you a different idea about the layout, the sizes, where are the doors, where can you put a table, all kinds of information. This is useful for a certain purpose. Okay, but each of them you can say is useless for different purposes, right? This is not telling you how tall it is. This is not giving you an idea of many other things about it. How sunny is it? Which part of the building does the sun rise and so on. We don't, a lot of things that you don't get information about here or here, but both are still useful for different purposes. Okay, so the point is the model useful? That's the main question. Right, so again, coming back to this, right, we thought this looked like an exact model. Why would you say this model is wrong? Well, this model may be wrong because we didn't look at all the data. If you went and looked at additional data, you may find that this model doesn't actually capture that. Okay, so in this sense, the model is not right. We only looked at a small set of the data, right? And you may say, well, what if you look at the complete data? Well, you cannot, because you don't know what future is going to bring to us, what the future is going to bring. We don't know that, right? And also historically, we may not have seen everything. Okay, so in that sense, the model is not reality. Okay, so here's an example. Famous examples of models, probably the most famous examples of models in the world. So here was Newton, right? And Newton came out with the theory of gravitation, laws of motion and stuff, and they were really good. Right, the Newton's laws of motion were good enough for us to launch geosynchronous satellites. Right, when we launch satellites, the calculations based on Newton's equations are enough. We've managed to put a human on the moon by using Newton's calculations, Newton's laws. We've managed to, in fact, reach Mars and do a lot of things with Newtonian laws. Right, so that's a model of the universe which served a certain purpose. Right, but still, it's wrong. Right, and who told us that? Einstein. Einstein figured out that the Newtonian model is actually wrong. Okay, and we in fact needed the Einsteinian model to do lots of things, to explain things like why does electromagnetism actually happen? In other words, when I move a coil nearby a magnet, why is there electricity produced in that coil? Well, that is explained by Einsteinian models. Okay, if you want to build a particle accelerator that's going to accelerate an electron to close to the speed of light, then you're going to have to perform calculations suggested by Einstein's model. Newton's model will not work there. When we have our GPS systems, they work. And in order to make them work, they need a level of accuracy which has to take into account relativistic calculations and so many other things, right? So Newton's model was wrong. We needed Einstein's model to come out to do all of these things, but still Newton's model was extremely useful and continues to be extremely useful and a piece of genius work actually. Okay, Einstein's model is probably still wrong. Somebody will have to go and find out what are the cases in which Einstein's model fails.